warahmatullahi wabarakatuh to our beloved lecturer Encik Zulkarna, and today our group will present about our project. I will present about introduction, objective and organization chart. The introduction of this project is to rationalize production part from the start to the completion of part design planning, so that the application and preparation to like equipment, machine and resources would be synergistic alike assembled, which end through engineering the design master plan. The title of this project is Master Root in bracket Radial engine. Master Root is a reciprocating type internal combustion engine configurations. This project also to apply the technique, plan machining strategies and toolpath method by using CATIA software. Now I will present about objective of this project. Objective of this project is students can learn the implementation of solid modeling and get hands-on experience with the real-world project. Students are also able to apply CAD/CAM procedure by using CATIA software. Third, students can use familiarity with geometric dimensioning and tolerancing in CATIA. Last, students know how to generate NC code operation and transfer to machine. Now I will present about organization chart. First of all, Encik Zulkarna bin Marjam is our supervisor. We have 5 group members, which is our leader is Izzuddin Fahmi bin Hadrawi. 4 of them is Muhammad Hakimi bin Harun Rashid, Warsawani binti Zamani, which is me, Cik Amimi Yasmi bin Cik Asudin, and last Nurul Afika binti Zulkifli.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Afika binti Zulkifli, and today I am going to present about the project management for the Master Root Radial Engine team. Okay, for the project planning, this project gives a wider experience to discover and explore the skills on the product design with a degree of complexity in terms of the dimension and the product design. And then these products are designed by using the solid modeling technique, plan machining strategies and toolpath methods. Also, we apply the procedure of the CAD/CAM programming using the CATIA software. Okay, basically the computer-aided design (CAD) involves creating computer models defined by geometrical parameters, whereas the computer-aided manufacturing (CAM) use the geometrical design data to control the automated machinery. Okay, and then move to the process flow of this project. Okay, firstly we collect the design data, the design idea into the CAD, where we sketch and do the 3D modeling, and then move to the CAM, where we make a tooling selection and machining operation, and also generate the toolpath file for the part. And then after that, move to the verification process, where we can analyze the toolpath error detection, tool collision, where it might and it can be happen sometimes. So we can analyze at this process, and also comes with the geometry verification. Okay, after that, for the post-processing, we will download the NC program, which we generated the NC code program before, and then the program we move to the CNC machining to make a finished product. But unfortunately, we stopped at generating NC code because we couldn't do the CNC machining due to the movement of the restriction. Okay, and then move to the Gantt chart. For the Master Root Radial Engine teams, we have planned about 8 planning, which is part selection, part approval, solid modeling, CATIA simulation and cutting strategy, tool setup and verify the NC code, project report documentation, project presentation and consultation. Okay, so in the week 1, we make a part selection, which we gather all the information, the design, the product data, and then move to the week 2 and week 3, we get the part approval from the lecturer. And then stop until there, because week 4 week 4 until week 9, we have the movement control order restriction and also the mid-sem break. After that, the movement control order extension until week 9. Okay, proceed. At the week 10, we do the solid modeling and then the CATIA simulation and cutting strategy and then tool setup and verify the NC code. We stop until verify and generate the NC code because we couldn't do the CNC machining. And then after that, we gather all the data, the drawing to make a project report documentation. And then in week should be presented in week 14, but it took a week after that, which is we presenting this project in week 15. Okay, for consultation, we make it as a continuous effort for our project with consultation with the lecturer from the week 1 until week 14. Okay, so that is for the Gantt chart for the master radial engine. Okay, that is all from me. Thank you.
Assalamualaikum, my name is Muhammad Hakimi bin Rasid and I'm going to present about project details, which is 3D modeling. For the first step, you need to sketch on the XY plane and make the dimension first. And then we pack the first sketch for 35 mm. After that, we need to draw a new sketch on the same XY plane and put the dimension on it. And then we pack the sketch 2 for 7 mm. After we pack the sketch 2, we need to mirror the pad on the XY plane, and then we make a new sketch on the XY plane, and then we pack the sketch for 42 mm, and then make a new sketch which is the sketch 4 and put the dimension on the plane YZ and make the pocket for 42 mm. And then we need to sketch for the 6th sketch and put the dimension. After that, we pack the sketch for 21 mm length. And then the last one is we need to sketch on the XY plane, which is sketch 7, and pocket the sketch for 14 mm depth and make the mirror for the pocket at XY plane. So as we can see, this is our multi-view product, which is we have top view, back view, side view and isometric view. And for the stop, first we need to click on the new body and create a rectangle and pad for the part. For the part, the height of for our stock is 38 mm. And then for the plane system, the blue plane represent for hold, red for rapid and yellow for approach. So the distance from the XY plane to approach plane is 15 mm, rapid is 30 mm, and the last one is which is home plane system is 100 mm. So for our process planning, the first one is process planning is called manufacturing planning, material processing, process engineering and machine routing. The second one is act of preparing detailed work instruction to produce a product. Process planning determine how the product will be produced or service will be provided. So this is our table for process planning.
Okay, for cutting tool creation, we have select 5 type of tool, which is face mill with diameter 50. Second, we use end mill with diameter 10. And third, we also use end mill diameter 10. And fourth, we use drill diameter 10, and for finishing we use end mill diameter 10. For part operation, there is 4 process that we do in machining. First is facing, second is roughing, third is pocketing, fourth is drilling. Okay, so we proceed in CATIA software. First, we must select the part operation, the machine, reference machining IC system, the design part for simulation for our part, the stock for the, we click for the stock. Okay. Next is the manufacturing program, which is the process here. So the facing use direction of cut is climb, machining tolerance is 0.1 mm, feature accuracy is 0.1 mm, type of contour is circular, and the mode for radial is maximum distance between path is 10 mm. The axial mode is maximum depth of cut, and depth of cut is 0.5 mm, and the finishing mode is finish bottom only, and the thickness is 0.5 mm. Here, this is the order that we want to choose to make the machine cut the part in correct order. Okay, and this is for the tool that we use is press mill with diameter 50, and for the feed and speed approach is 300 and the retract is 1. And here we can see the approach and retract is already active, so we can proceed the simulation here. Okay, so the machine operate with the correct order, so we can continue the next spacing. The first one is for the top, and the second one is for the bottom. And for the bottom, we use the same with the same order like the top one here, 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 and also same. And the tool is same, is space mill diameter 50, and the feed and speed approach is 30, retract is 1000, approach is and retract is already active. Can proceed to the simulation. Right. So we proceed to the next process is roughing. Also same with the facing top and bottom. For the machining mode is by area and the outer part for the tool part style we choose the spiral. The machining tolerance is 0.1 mm. The cutting mode is climb, and the radial for the step over is overlap ratio, and the tool diameter ratio is 50. Axial, the maximum cut depth is 5 mm. Okay, so this is for the order. This is for the rough stock. We can choose here. Here. And for the part, we choose our part. And for the tool is end mill, diameter 10. And for the speeds and speed approach is 30 and the retract is 100. And for the automatic pre-motions and post-motion is have been active, so we can proceed to see whether the machine operates in correct order. Okay, for the top is finished, and for the bottom is same with the top. Okay, here, 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 same order, and the tool is same and mill diameter 10. Approach, automatic pre-motion and post-motion. So we can proceed the simulation for the bottom. So the next process is pocketing. Also same top and bottom. So toolpath style, we choose the outward helical direction. Machining direction of cut is climb. Machining tolerance is 0.1 mm. Pitch accuracy 0.1 mm. Position is 1. Radial mode is maximum distance. Distance between path is 10 mm. And for the axial mode is maximum depth of cut. Depth of cut is 0.2 mm. And for the finishing mode is side finish last level. And to do the order, there is 3 types: here, here, and here. And for the tool is end mill diameter 10. The feet and speed is approach 300 and retract is 1. Here we can see the approach retract is already active. You can see the simulation. Okay. So the top is in good order. Okay. So we can proceed for the bottom. So the order is same with the pocketing to the top. Okay. Here, here. So we see the simulation. Okay. So finish. Okay, next, the last process is drilling. To drill the hole, four hole here. So we choose for the approach clearance is 0 mm. Depth mode is by shoulder. Force compensation is 1. And here, for the length to drill the hole is 70 mm. And the diameter of the hole is 10 mm. 10 mm. For the toolpath is drill diameter 10. The approach of feet and speed is 300 mm and the retract is 1000. Here we can see the approach and retract also have been active. We proceed for the simulation. Okay. Here we can see the process has been finished. The product of ours is have a good cutting. So after this, we are going to generate the NC code. First, we do the option of the tool, select the IMS, and the NC.code we replace to the file that we want to save, and the extension we change to the NC code. After that, we click OK. And next, we proceed to the generate NC code interactively. Here we choose for the selection is program. The NC data type is NC code, and one file is for all selected program. And for the NC code, usually we use for the Siemens at 140. And so we execute, okay, and then we search the NC code at the file that we want to save. Okay, so that's all for today. Thank you.
I will continue my presentation with my part, which is summary. In summary, there are conceived three parts, which is result, discussion, and conclusion. So, without any constraint, shall I elaborate on our result? So, in our slide for the first picture, it is the final result of the simulation for master road. For achieving the simulation, my friend has already told in the previous slide. And the second picture is isometric drawing. Basically, on the isometric drawing, there are considered four parts, which is isometric view, front view, side view, and top view. Next, I will continue with discussion. Based on our project, I can conclude that there were a small couple problems that we have faced, which is we have to decide the dimension of the master road. It is because we don't have the actual part of the master road. So, we have to find and decide the dimension of the product to apply in software. Second, when doing this project by using CATIA software, our computer always lagging. It is because the computer cannot support the software. Next, the difficult parts when doing this project is when we want to apply the advanced machining. In this case, it took us several days to us to try and figure out the error of the product. Sometimes there were some area that cutting tools cannot move to the point. So in this case, it is difficult to us to figure out this error. Next, in this project, I can conclude that the overall goals of this project is achieved. Students able to apply the technique of the CAD/CAM software. This project gives a lot of knowledge and skill to us by using the CAD/CAM software. Next, it also gives us how to manage the work in groups to complete this project by dividing these tasks. Lastly, I can conclude that there are many advantages by using CAD/CAM software. For example, CAD/CAM software can increase the productivity of designer, and it also can improve the quality of design.